For our first hypothesis test example, we're going to use the p-value approach for a large sampled z-test. Now, from our previous lesson, I want you to recall that we have our rules that decide for us whether we reject or fail to reject our null hypothesis. So when we calculate our p-value and that value is less than or equal to alpha, that makes the decision to reject the null hypothesis. However, if our p-value turns out to be greater than our alpha value, then we will fail to reject our null hypothesis and then can finish the decision based off of where the claim will be. So in our first example, we have a large sample of 100 Americans selected, and we're looking to find out whether Americans are exceeding the daily sodium intake of 3,300 milligrams. So when we're looking at exceeding this limit, mathematically, that means that we are greater than 3,300. Because that is testing greater than 3,300 milligrams, we're going to put that claim into the alternative hypothesis. So this is a claim for a large sample mean, and I'm going to identify that's where my claim is going to go. My null hypothesis will be the exact opposite of that, and that will be that it's less than or equal to 3,300 milligrams of sodium. In this test, I'm asking you to use an alpha of 0.05. So that's going to be determining our level of significance. That's what the number that we will compare to our p-value in a few moments. Now, to determine our test statistic, since our mean test is greater than 30, then we are going to use a standard z-score test. So I'll look at my sample, and my sample said that the mean sodium intake was 3,400 milligrams minus my hypothesized mean divided by my standard deviation over the square root of my sample size. I'm just using the standard z-score formula for a sample. When we do that calculation, I get a z-score of approximately 0.91. Now, since our test is an alternative hypothesis of greater than, when I look at my normal distribution, I am going to draw a right-tailed test where I'm looking up the area of a z-score of 0.91. I'm going to look for that area, and that area becomes my p-value, my probability value. Now, when I use my standard normal distribution table, I'm going to go ahead and look up 0.91. When I look that up on my normal distribution, I find the area all the way to the left of 0.91 being 0.8186. Because it's the area to the right, I will need to use the complement and identify that area to be 0.1814. That becomes my p-value. My p-value is the area of my test statistic. In this problem, it is 0.1814. Now, that takes my decision. If I compare my p-value to my alpha, and my p-value is 0.814 and my alpha is 0.05, I can clearly see that my p-value is greater. If I go back up here to my decision, that means that I am going to fail to reject the null hypothesis. Now, because I'm failing to reject the null hypothesis and my claim is in the alternative, then I do not have enough evidence to support my claim. So there is not enough evidence to support the claim that Americans exceed an intake of more than 3,300 milligrams of sodium per day. Now, because my alpha is set at a significance of 0.05 and I have failed to reject the test, I have a chance of a type 2 error because of failing to reject the test. So I'll mention at the 0.05 level, there is a chance of a type 2 error. That comes into existence anytime we fail to reject our null hypothesis. Then we will always have a chance of a type 2 error. So that's what it looks like to complete a large sample p-value test, hypothesis test.